A very warm welcome to everyone. In this video, we'll discuss about a dynamic routing protocol, open shortest path first protocol. The last videos we have discussed about dynamic routing protocol, that is RIP. We'll see OSPF and we'll see what are the difference between the OSPF and RIP at the end. So what is OSPF? OSPF stands for Open Shortest Path First. It is a dynamic routing protocol which uses a link state algorithm to find the best path for data packets in network. So which means OSPF is a dynamic routing protocol which will use link state algorithm. We'll see what is link state algorithm is. It is an interior gateway protocol, which means it operates within a single autonomous system. It is designed for large and complex networks, whereas we have discussed about RIP, which is having a limitation of 15 hops. More than 15 hops, if a network has to go, then we can't go with the RIP. Whereas OSPF can be used for large and complex networks, which is having a faster, more efficient, and more scalable um, capacity than RIP. Basically, OSPF routers exchange the link state advertisements, which describes who are directly connected networks to them. Each network which will build a complete map of network topology, and this topology we call it as a link state database. Using this map, like a map of network topology, every router independently will calculate the shortest path. This is done using the algorithm called as Dijkstra algorithm. So Dijkstra algorithm is used to find out the shortest path in the OSPF. OSPF, after calculating shortest path, will chooses the best path based on the lowest cost. Here, the cost indicates the bandwidth. So which means which is using lesser bandwidth will be more used. Then how this OSPF works? The first step, it is very simple. It is discovering the neighbors. So just like saying an hello, routers also will send hello packets to discover the other OSPF routers on the same network. It will not go with beyond its neighbors. Within the network's neighbors, it will say hello packets, send hello packets, and then discover the neighbors. Once it is discovered, then it will exchange the link state advertisements. Routers will share the information about their links, which means who are my interfaces, what is the cost, um, what who are my neighbors. All these informations will be shared, exchanged using the link state advertisements. Once this advertisements is done, then it will build a topology table based on the information which is received. This is done by each router in the network. Will construct a complete topology of the network. Once the topology is constructed, then we'll be able to run the register algorithm to find out the shortest path to all the destinations. And once it is done, it will keep on updating its routing table. This is the 5 steps working process of OSPF. Now, we have taken a scenario here. You can see we have two networks, network A, and we can see a network A and network B. In between network A and B, we have some three routers. So each router R1, R2, R3 will send hello packets to find the neighbors. They exchange the link state advertisements, which will describe their connected networks. Then after that, each router will build its own topology database. Then after using the register algorithm, they will find out shortest path to reach the all other neighbors. If a link between R1 and R2 or R3 fails, quickly it will calculate to find out an alternate path. Typically within some few seconds, it will do the finding out a new path if any path is breakdown. Very key features of the OSPF, basically it will use link state routing protocol, and the algorithm to find out shortest path, as we have discussed, it is register shortest path first algorithm. And here the cost is calculated as a metric which is based on the bandwidth, And as I said, it is an interior gateway protocol. Um, the transportation protocol which is used is IP, and it is not periodic updates. Whenever there is some sort of change, only in that case this triggered updates will happen so that it will avoid the flooding of networks. The convergence is very nice, very good, very fast convergence. Even if some link breaks down immediately, it will start finding out the alternate path. And it will support both VLSM and CADR. Both it will support. And authentication for security purpose, it will use MD5 or suppose plain text also it will support. And the areas normally supports hierarchical routing using areas, and mainly it is backbone area 0. We'll talk more about this areas, which is very interesting concept. We have various types of routers. Internal router, which are where all the interfaces are in the same area, and we have something called as the backbone router. The router which is basically sitting in the area 0 is called as the backbone router, and we have something called as area border router, which means which will look like a border security, which will connect multiple areas. And we have very important one called as the autonomous system border router, which means connecting OSPF to any other protocols outside world or to ISPs, that is BGP, RIP to external members, that is autonomous system border router. I have given a small example here where we have um, multiple routers we have. Can you see here? We have an OSPF area 1, OSPF area 2, and we have some internet or something else is there. Service providers are there here. Now we can see this is called as the area 0 or backbone area because all the other routers in the other areas are connected using the area border routers to the backbone area. So backbone area 0 will have a link to all the other areas. That is why it is called as the backbone area. So area 0 means which is giving connection to all the other areas. So here OSPF will divide the network into areas to reduce the routing overhead. And area 0, as I said, it is a backbone area, and all the other areas are connected to this backbone area. Routers which will connect to or more areas are usually called as the area border routers. They summarize and share the routing information between those areas. And here we have a special person called as ASBR, which means Autonomous System Border Router, which will connect your area 0 with the outside world, which means internet, RBF, it is any ISPs, BGP, it will try to connect the autonomous system border router. There's a router inside an OSPF area which can import or redistribute the routes from outside OSPF into the OSPF network. So these are the different OSPF areas. We have area 0, area 1, area 2. We have something called as the area border router, and we have someone called as the autonomous system border router. And what are the advantages of the OSPF? The main advantage of the OSPF is the fast convergence, which means it will recalculate the routes immediately if there is a change, and it is scalable. It will work efficiently in a very large scale network, and it will support both VLSM and CIDR so that it will be able to handle the complex subnetting. And it is loop free routing, which is very, very important. Loop free routing because it is using the register algorithm to find shortest path, and it will give an efficient updates. As I told, it is not periodic updates, it is triggered updates, which means only when there is a change, it will give us an update. And for security, as we said, we are using MD5 or plain text sometimes for the authentication. And the design is completely hierarchical design. And though there are some good advantages, we have few advantages. The configuration is a little bit complex, and it requires more knowledge than the simple RIP because RIP is having a limitations of only 15 hops there, and we have more CPU and memory usage. To maintain topology database, we need to use more memory and CPU, and it is difficult to troubleshoot if it is having multiple areas, and it is not ideal for very small or simple networks. If it is a bigger network, a large network, a complex network, always we can go with the OSPF. And where OSPF is used. Practically, it is used in branch office connectivity where we have an headquarters is area 0 and each branch is separate OSPF. For example, if I take a college, the college administrative office will be connected to all the other departments. So administrative office is called as the area 0, whereas all the other departments are connected directly to the administrative office. So area 1, 2, 3, department 1, 2, 3 are all connected to the admin office, that is your administration office, which is called as the headquarters or area 0. So and then data center routing, which is connecting the core distribution and access switches with very fast convergence, and it will redundant WAN link failover. If suppose any switching between MPLS or lease line, anything is fails, automatically it will try to switch. And equal cost multipath load balancing is also one of the place where we use the OSPF. And for large campus or multi-building networks, as I said, we can divide the buildings floors into areas, and to reduce the links to advertisements flooding and improve performance, we can always go with the OSPF. So basically, as I said, what are the difference between the RIP and OSPF? By now you would have understood just a glimpse. So algorithm, it is here is using RIP is using the distance vector, whereas OSPF is using the linked state algorithm. In the case of metric here, maximum count is 15, that is hop count is taken as the metric, whereas here there is no limit for the hops, whereas we calculate the metric cost using the bandwidth, and the convergence is very slow. When something fails, it's very difficult to fix it over. Um, Whereas OSPF convergence is very nice, very good. Convergence is there. Updates for every 30 seconds we have an update. Here only trigger updates are available, so that we need not worry about the network if there is no updates, and supports only in the version 2, whereas it always supports the VLSM, and it is suitable for small networks, whereas OSPF is always suitable for the larger networks. It's always recommended for the complex networks. And RIP is version 2, whereas authentication is also provided in OSPF in a very good manner using the MD5 authentication, security authentication, transport protocol. Here we are using UDP for RIP, whereas OSPF uses the IP protocol. That's all. Next class we'll discuss about VLANs. Before that, we'll try to implement the OSPF in the upcoming session. Thank you.